Hello, so this is going to be a hopefully short video on just me kind of explaining a couple things about e to the x and reiterating it to a couple things from the past. So I want to call to attention something I just proved recently, that the derivative of a to the x is equal to a to the x times the natural log of a. So keep that in mind. And I want you to remember that the derivative of a to the x in terms of the difference quotient, I wrote it as a to the x times the limit delta x approaching 0 of a to the delta x minus 1 over delta x. And if you're wondering where I got that from, I wrote it in a previous video. I believe it's called just derivatives of exponential functions. It's not the part 2 one, and it's not the proof. It's, believe, the original one, where I just kind of elaborate a little bit on this, I guess. Uh, but yeah, so this itself, I I want to kind of hopefully show you that if you were to, um, well, here, if I tell you that this part right here, if I move this out of the way and I move this out of the way, we know that these are both derivatives um, of a to the x. So I can say that they're equal to one another, right? So hopefully you can see that this a to the x right here and this a to the x right here are doing the same job, and that this natural log of a and that this limit right here, these must be equal because of that, right? Um, so we're basically saying that this natural log of a is equal to the limit as delta x is approaching 0 of a to the delta x minus 1 over delta x. And because that's true, that helps us understand a little bit as to why e is so important here. Because, and we couldn't really evaluate this before. We could plug in e right here, but like, what's it going to do? It's not really going to tell us much. But now, if we know that these are equal, we can say that the natural log of e is just 1. So that suddenly makes sense, right? Because the natural log of e times a to the x right here, which is now going to be e to the x, is e to the x. So now you can actually show that it's e to the x rather than me just telling you that it's e to the x, right? And I did show earlier how to express e to the x in terms of a limit. So if you want, you can go ahead and kind of fiddle with that a little bit more. There's also probably some videos out there on YouTube otherwise. Um, but essentially, that's most of this. So it's really just intuitive. If you were to consider it as just the limit as delta x is approaching 0 of e to the delta x minus 1 over delta x, this is equal to the natural log of e. So I think that's just really interesting. How we're able to take this kind of obscure limit and turn it into a simple natural log. This works for um, anything. Like I said, originally it's just going to be base a here instead of e, and it'll just churn you out whatever your base is. So I think that's an interesting way to calculate or express natural logs, and it clearly shows up here as working.